On December 28th, a scientific speculation emerged suggesting that the James Webb Space Telescope had detected a massive artificial geometric structure surrounding the interstellar object 3E Atlas. This structure was described as emitting prime number sequences and mathematical data signals that are often regarded as potential indicators of extraterrestrial intelligence, with an exceptionally advanced level of technology. According to the speculative account 3I Atlas, not only exhibited anomalous behaviour, but was also claimed to have released 17 smaller entities, which are gradually establishing a spherical ring around Earth, possessing acceleration capabilities far beyond the limits of any known material or existing technology. Through the perspective of Professor Michio Kaku, the hypothesis was put forward that Earth may currently be in a state of cosmic quarantine, and that humanity may have remained within the observational scope of an advanced civilization for a very long time. These elements are linked to a specific point in the near future identified as January 2026, or approximately 41 days from the present, and are described as a decisive turning point in the history of humankind. Immediately after this, we will turn to the latest hypotheses that scientists have proposed regarding Atlas. The moment the James Webb Space Telescope registered the anomaly, the data did not announce itself with drama, but with quiet defiance. The instrument surrounding 3 Atlas reported a configuration that did not drift, shimmer, or decay, but instead resolved into order with unsettling precision. Around 3 Atlas, space itself appeared to organise not gradually, not probabilistically, but decisively, as though responding to a set of instructions that predated observation. Within a span measured not in hours or days, but in minutes, a vast hexagonal lattice emerged around 3 Atlas, extending nearly 400,000 kilometres across the surrounding vacuum. The scale alone was disorienting, yet the symmetry was more troubling because symmetry of this kind does not arise spontaneously in low-energy cosmic environments. Every node of the lattice surrounding 3 Atlas aligned with mathematical consistency, forming angles and distances that resisted attribution to turbulence, gravity, or chance. Astrophysical models describe self-organization as a slow negotiation between chaos and constraint, but the structure enclosing 3 Atlas bypassed negotiation entirely. The lattice did not grow, it appeared, and the distinction mattered because growth implies causality, while appearance implies intention. In the presence of 3 Atlas, quantum fields that normally fluctuate without preference behaved as though guided toward equilibrium by an unseen framework. Data analysis confirmed that the formation time of the lattice around 3I Atlas was approximately 17 minutes, a duration so brief that conventional mechanisms could not account for the transfer of energy and information required. No known astrophysical process could marshal dispersed quantum states into coherent geometry at that speed, without leaving signatures of violent interaction. Yet around 3I Atlas there was no debris, no shockwave, no thermal bloom, only structure suspended in silence. The hexagonal form itself introduced a deeper unease, because hexagons occupy a rare position in natural systems as shapes of maximal efficiency under constraint. In planetary atmospheres, crystal lattices and biological tissues hexagons emerge when systems optimize energy distribution, but the lattice surrounding 3 Atlas exceeded all such analogies in scale and coherence. Here optimization did not follow from environment, but appeared imposed upon it. As the lattice stabilized around 3 Atlas, researchers noted that the geometry did not interact with nearby matter in any measurable way, suggesting containment rather than construction. The space within the hexagonal network behaved normally, while the boundary itself acted as a mathematical demarcation rather than a physical barrier. This distinction reframed the event because 3 Atlas was no longer simply accompanied by structure, but positioned at the center of a defined spatial condition. The formation of the lattice invited a single persistent question that resisted immediate articulation. If natural processes require time to organize complexity, what operates when complexity arrives fully formed around 3 Atlas? And if the universe allows such precision to exist, why had it chosen this moment and this visitor to reveal it? As the hexagonal lattice surrounding 3 Atlas settled into stability, attention shifted from shape to signal, because geometry alone could still be dismissed as an extreme but natural optimization. What followed around 3 Atlas removed that comfort as the lattice began emitting rhythmic pulses that were neither random nor continuous. Measurements revealed that the nodes embedded in the structure around 3A Atlas oscillated according to discrete numerical intervals. Those intervals aligned precisely with prime numbers, beginning with 2 and advancing through 3, 5, 7, 11 and 13 without deviation or overlap. In physical systems, primes rarely appear without mediation because nature favours aggregates and harmonics rather than indivisible sequences. The persistence of prime number signalling around 3I Atlas forced a shift in interpretive framework. Prime numbers do not compress easily, do not simplify through symmetry, and do not arise efficiently through stochastic processes. When primes appear in ordered progression, they function less as quantities and more as declarations of structure. In the decades-long search for extraterrestrial intelligence, primes have occupied a singular role as the closest thing to a universal signature of cognition. They do not rely on biology culture or sensory modality, and they remain invariant across reference frames. By employing primes, 3 Atlas appeared to reference not a language but the concept of language itself. Further analysis showed that the pulses around 3 Atlas were not merely numerical markers, but carriers of encoded ratios. Those ratios mapped cleanly onto known physical constants, including the speed of light Planck's constant and the fine structure constant. The implication was subtle, but profound because constants define the rules of reality rather than its contents. Rather than transmitting information about objects or events, the signalling around 3I Atlas appeared to establish a baseline of mutual comprehension. This pattern resembled what theorists describe as a handshake protocol, a preliminary exchange designed to confirm shared understanding before communication proceeds. Such protocols assume not only intelligence, but anticipation of another intelligence capable of recognition. Crucially, the prime sequences associated with 3 Atlas exhibited no redundancy. There were no repetitions, no corrective loops, and no evidence of error checking typical of noisy environments. This absence suggested confidence as though the sender expected to be understood without clarification. The emotional response among observers was restrained but unmistakable. Prime numbers evoke order without warmth, intention without expression, and certainty without explanation. In the presence of 3, Atlas mathematics ceased to feel abstract and instead assumed the weight of attention. If geometry defined the boundary around 3 Atlas, then mathematics defined its voice, and if that voice existed, then silence was no longer the default state of the cosmos. The dynamical behaviour of 3 Atlas presented an anomaly that persisted even after geometric and mathematical interpretations were set aside. In classical celestial mechanics, motion follows from mass velocity and interaction, yet 3 Atlas refused to conform to those expectations despite exhaustive modelling. Observational data indicated that 3 Atlas travelled through the inner solar system at velocities exceeding 100,000 km per hour. Such speed alone did not violate physics, because interstellar objects often arrive with excess kinetic energy, but 3 Atlas carried that velocity without displaying the usual physical responses. Comets approaching a star normally exhibit sublimation, rotational torque and asymmetric mass loss, yet 3 Atlas produced no detectable coma, no dust tail, and no measurable outgassing. Spectroscopic surveys targeting 3I Atlas further deepened the inconsistency. The surface composition inferred from reflected light revealed elemental ratios that did not align with known stellar formation pathways. Around 3I Atlas, volatiles expected to vaporize under solar radiation remained bound, as though thermal interaction had been deliberately mitigated. The absence of non-gravitational acceleration signatures around 3I Atlas was particularly unsettling. In natural objects, even minimal heating introduces stochastic deviations, but trajectory reconstructions showed that 3I Atlas maintained an almost idealized path. Minute corrections that would normally arise from chaotic microforces were either absent or counterbalanced with remarkable precision. Astrodynamic simulations tested whether 3 Atlas could be explained as an unusually dense or inert body. Those models failed because density alone cannot eliminate thermodynamic exchange, nor can inertia suppress all perturbative effects. Each attempt to reconcile the motion of 3 Atlas with passive matter required increasingly contrived assumptions. As discrepancies accumulated, the behaviour of 3 Atlas began to resemble controlled motion rather than inertial persistence. The trajectory of 3 Atlas appeared refined, not optimised for efficiency alone, but stabilised against environmental interference. Such stabilisation implies feedback, and feedback implies awareness of state, rather than submission to force. The realization did not arrive as panic, but as a quiet recalibration of expectation. 3. Atlas no longer occupied the category of anomalous debris because debris does not resist interaction with such consistency. Instead, 3 Atlas suggested the presence of a system designed to move through space without announcing itself through entropy. This interpretation did not require assuming intent, but it demanded acknowledging design-like outcomes. Whether 3 Atlas was constructed, modified, or guided remained unresolved, yet the motion of 3 Atlas no longer felt accidental. In this context, dynamics ceased to describe movement, and instead began to describe restraint. As attention shifted toward energy scales capable of sustaining such restraint, the questions surrounding 3 Atlas transitioned naturally from motion to capacity. What kind of civilization, if any, could afford to let physics remain silent around a traveller like 3 Atlas? The question of energy inevitably followed the observations because the behaviour of 3 Atlas could not be sustained without access to power far beyond human engineering. When motion structure and restraint converge without visible expenditure, energy must be inferred rather than observed, and 3 Atlas demanded inference at an unprecedented scale. The Kardashev framework provides a vocabulary for such inference not as a prediction, but as a measuring tool for technological reach. Within that scale, a Type 1 civilization commands planetary energy, a Type 2 harnesses stellar output, and a Type 3 manipulates the energy of entire galaxies. The systems implied by 3 Atlas did not align comfortably with the lower tiers of that spectrum. To assemble and maintain a lattice hundreds of thousands of kilometers wide around 3 Atlas would require sustained energy coordination rather than momentary release. The absence of waste heat around 3 Atlas suggested not efficiency alone, but mastery over energy dissipation itself. Such mastery implies a civilization that treats energy not as fuel, but as a controllable medium. The comparison often invoked by analysts was deliberately conservative. If modern satellites represent the pinnacle of human engineering, then the mechanisms associated with 3 Atlas occupied a category so distant that analogy collapsed under its own weight. Stone tools did not merely differ from quantum computers in degree, but in conceptual foundation, and 3 Atlas appeared to operate from a similarly alien premise. More unsettling than scale was precision. Energy usage around 3 Atlas appeared distributed evenly across the structure, suggesting centralized coordination without centralized emission. This pattern implied not only abundance, but governance of energy flows at resolutions humans have not learned to define. Within the Kardashev context, 3 Atlas could plausibly reflect a Type 2 civilization exercising localized intervention, or a Type 3 system deploying a minimal probe. Both interpretations converged on the same implication, which was that 3 Atlas represented restraint rather than maximal display. The energy required was immense, yet the expression of that energy was deliberately muted. This restraint reframed the emotional impact of the observation. 3 Atlas did not overwhelm the solar system with power, but instead demonstrated the ability to operate invisibly within it. Such discretion suggested maturity, not aggression, and capacity without urgency. As researchers contemplated these scales, the unease did not arise from imagined threat but from relative insignificance. 3 Atlas implied a technological horizon so distant that humanity's position became contextual rather than central. In that context, the Kardashev scale ceased to feel speculative and instead felt descriptive of a reality humanity had just begun to glimpse. The decoded imagery associated with 3 Atlas did not depict the present Earth, but instead resolved into a reconstruction of the planet as it existed 65 million years ago. This temporal displacement reframed the signal from 3 Atlas because it suggested historical awareness rather than contemporary observation. At that epoch, Earth was warmer, continents occupied unfamiliar positions, and dominant life forms bore little resemblance to those shaping the modern biosphere. The image transmitted alongside 3 Atlas showed coastlines before human memory, forests before grasslands, and oceans carrying chemical signatures long erased. Superimposed over this ancient Earth was a geometric symbol whose simplicity contrasted sharply with its implications. 3 Atlas presented a circle intersected by a single line, with 3 smaller circles orbiting the point of intersection rendered with precise proportionality. The symbol associated with 3 Atlas resisted immediate interpretation because it did not resemble linguistic glyphs or mathematical operators. Instead, the symbol functioned as a conceptual marker, compressing meaning into form rather than instruction. Analysts began to associate the symbol with containment, not confinement through force, but isolation through designation. In biological systems, quarantine is not punishment, but a mechanism of protection preserving both the isolated entity and its surrounding environment. The pairing of this symbol with an image of prehistoric Earth suggested that 3 at last was not referencing a singular event but a recurring condition. Extinction events are embedded in Earth's history, and the most famous of these reshaped evolutionary trajectories without erasing life itself. By selecting this moment, 3 at last appeared to anchor its message at a threshold of transition rather than annihilation. The end of the dinosaurs was not the end of Earth, but the clearing of ecological space for new complexity to arise. This contextual framing shifted the emotional tone of the message associated with 3i Atlas. Rather than communicating threat, the imagery implied oversight, as though Earth had been observed through cycles of disruption and renewal. The quarantine symbol took on additional nuance when interpreted through this lens. Quarantine in ecological management does not imply hostility, but intervention calibrated to long timescales and systemic balance. 3. Atlas therefore introduced the possibility that Earth had long been categorized rather than ignored. Such categorization would require persistent observation, extending far beyond the lifespan of civilizations. The unsettling implication was not that humanity had been singled out, but that humanity had emerged within a monitored environment. If 3 at last referenced quarantine, then the status applied not to humans alone but to the planet as an evolving system. This interpretation introduced a quiet tension rather than fear. 3 at last did not announce judgment but suggested precedent continuity and process operating across geological time. By invoking an ancient Earth, 3 at last reframed the present as a moment within a much longer evaluation. In doing so, 3 at last transformed the question from whether Earth was isolated to why Earth had been allowed to develop as it had. After establishing a view of Earth deep in geological time, the signal associated with 3 Atlas shifted its focus toward human history, not as narrative but as sequence. The transition was subtle yet unmistakable, because 3i Atlas replaced spatial imagery with temporal rhythm, suggesting that time itself had become the medium of reference. Pulses emerging from the structure surrounding Atlas began to align with intervals that matched key inflection points in human development. These intervals did not correspond to calendar dates, but to transformative thresholds, moments when human organization altered its relationship with energy, information, and scale. The first pulse aligned with the agricultural revolution, when scattered populations transitioned into stable systems capable of surplus and long-term planning. In the framework implied by 3 Atlas, this moment represented the first sustained manipulation of ecological processes rather than mere participation within them. The next interval compressed dramatically, aligning with the rise of industrialization, when mechanical power allowed humanity to amplify output beyond biological limits. Here, Atlas appeared to mark the point at which energy consumption became exponential rather than cyclical. A further compression followed corresponding to the digital revolution, when information detached from physical constraints and began to propagate at near light speed. Through this sequence, 3 Atlas did not describe progress but acceleration, as though charting the curvature of a rapidly steepening trajectory. What distinguished this temporal pattern from historical analysis was its directionality. Rather than extending backward indefinitely, the pulses associated with Atlas converged toward a point that had not yet occurred. Each successive interval shortened not linearly, but exponentially, mirroring models of technological acceleration that predict discontinuity rather than plateau. In this context, 3 Atlas framed human history as a countdown not toward destruction, but toward transition. The projected convergence of this sequence resolved into a near-future date, one that lay within a human lifetime rather than across epochs. Atlas did not annotate this date with symbols of threat or reward, leaving interpretation suspended between anticipation and uncertainty. Emotionally, the effect was disquieting in its restraint. 3 Atlas did not rush the observer, but it also did not allow for denial, because the mathematics of acceleration are indifferent to intention. If the earlier image suggested long-term oversight, then this temporal compression suggested imminent relevance. Atlas appeared to recognize humanity not as static, but as approaching a threshold where qualitative change becomes unavoidable. This interpretation reframed the notion of countdown itself. Rather than measuring time remaining 3 I-Atlas seemed to measure readiness using transformation rather than survival as its metric. In this light, the sequence did not ask what humanity would do next, but whether humanity understood what it had already become. The most abstract component of the transmission associated with 3 at last emerged only after temporal patterns had been established, as though at last required context before presenting its most demanding material, rather than data describing objects or events. 3 at last introduced a conceptual scenario that unfolded as a structured dilemma. The scenario presented by at last described a civilization that had achieved digital continuity of consciousness, allowing individual minds to persist indefinitely within computational substrates. In the framework implied by 3 at last, biological limitation had been overcome, memory preserved, and identity stabilized beyond the decay of organic matter. At first glance, the premise appeared to describe triumph, because survival without exploration has long been framed as an ultimate technological goal. However, 3 at last did not end the scenario at achievement, but extended it forward into consequence. Within the constructed model, the civilization maintained perfect continuity, but gradually lost variability. Creativity diminished, risk vanished, and novelty became statistically improbable as optimization replaced exploration. 3 at last framed this outcome not as failure of technology but as fulfillment of its logic. The dilemma embedded by Atlas did not ask whether immortality was possible, because that question had already been answered within the scenario. Instead, 3 at last asked whether existence without transformation could still be considered survival. This distinction marked a shift from technical evaluation to philosophical measurement. Logical systems could not resolve the question, because no contradiction existed within the scenario. Artificial intelligence models analysing the transmission associated with Atlas identified coherence but failed to assign value. By presenting a dilemma without a correct solution, 3 at last appeared to probe not intelligence but judgment. The scenario forced confrontation with trade-offs that cannot be optimized simultaneously, such as stability versus growth and preservation versus meaning. Emotionally, the effect of the scenario was subtle rather than alarming. 3 at last did not condemn the hypothetical civilization, nor did Atlas celebrate it. The absence of moral signalling suggested that the evaluation criteria lay outside human categorical instincts. In evolutionary terms, the dilemma echoed long-standing questions about adaptation. Species that stabilize too completely risk extinction through inflexibility even when resources are abundant. Atlas appeared to extend this principle beyond biology into cognition itself. The implication was not that immortality was forbidden, but that immortality alone was insufficient. 3 Atlas framed consciousness as a process rather than a possession, something defined by change rather than duration. This framing aligned with earlier elements of the transmission which emphasized thresholds and transitions over endpoints. Atlas did not describe a destination for humanity, but outlined conditions under which destinations lose relevance. As a test, the scenario did not require an answer to be transmitted. Instead, 3 Atlas appeared to measure recognition, the capacity to perceive the underlying tension without resolving it prematurely. If the earlier temporal sequence suggested acceleration, then this dilemma suggested direction. 3 Atlas implied that advancement without wisdom leads not to collapse but to stagnation that appears indistinguishable from success. In this sense, the puzzle associated with Atlas functioned less as a question and more as a mirror. By contemplating the fate of an immortal civilization, humanity was invited to examine the assumptions guiding its own trajectory. The cumulative elements of the transmission associated with 3 Atlas converged toward an interpretive framework that extended beyond observation and assessment. Rather than depicting a singular intervention, 3 Atlas suggested a long-term role that operated across planetary life cycles. This role has been described by some theorists as that of a galactic gardener, not as a metaphor of control, but as one of stewardship. In managed ecosystems, gardeners do not design life from nothing but regulate conditions under which complexity can emerge, persist and renew. 3 Atlas appeared to reference such regulation at a cosmic scale, where intervention is rare, delayed and calibrated to developmental thresholds. Evidence supporting this interpretation emerged from the temporal alignment between Atlas and pivotal moments in human advancement. The arrival of 3 Atlas coincided with humanity's rapid progress in artificial intelligence, genetic engineering, and planetary-scale environmental impact. These technologies represent transitions from passive evolution to active modification of life and environment. Within this context, 3 Atlas did not appear as a catalyst but as a response. Atlas seemed to recognize a shift from emergence to agency, a point at which a civilization begins to influence systems beyond its capacity to fully understand. The Gardner hypothesis reframes extinction events not as acts of erasure, but as resets that preserve long-term diversity. From this perspective, the disappearance of dominant species can create ecological space for new forms of intelligence. 3 Atlas' reference to ancient Earth aligns with this view, suggesting continuity rather than interruption. Importantly, the Gardner role does not imply omniscience or benevolence. It implies adherence to a principle that prioritizes systemic balance over individual outcome. 3. Atlas therefore introduces a moral framework that does not center on intention, but on consequence measured across epochs. Emotionally, this interpretation replaces fear with unease rooted in humility. Humanity has long assumed isolation or insignificance as default conditions. 3 Atlas instead suggests inclusion within a managed environment where freedom exists but only within bounds not previously perceived. The Gardner framework also explains restraint. If Atlas represented enforcement, overwhelming displays of power would be unnecessary and counterproductive. Subtle signaling and delayed engagement would suffice to guide outcomes without destabilizing the system. This possibility alters the emotional profile of observation itself. To be seen by 3 Atlas may not indicate imminent judgment, but transition into visibility within a larger ecological context. In such a system, civilizations are not punished for growth, but monitored for imbalance. 3 Atlas does not clarify whether humanity is approaching cultivation, pruning, or integration. Instead, Atlas positions humanity at a moment where classification becomes unavoidable. The Gardner hypothesis does not answer what will happen next. It only suggests that what happens next may not be decided solely by human intention. The first unequivocal departure from conventional physics emerged when 3 Atlas altered its trajectory far beyond the region where thermal forces could exert influence. At distances exceeding 7 astronomical units from the Sun, 3 Atlas resided in an environment too cold to support sublimation, radiation pressure asymmetry, or volatile-driven thrust. In natural interstellar objects, trajectory deviations arise from uneven heating and material loss, but those mechanisms require proximity to a stellar source. 3I Atlas, however, demonstrated measurable angular adjustment while immersed in deep thermal equilibrium, where solar input becomes functionally negligible. The recorded deviation measured approximately 0.3 of a degree, a value small in appearance but enormous in implication. For an object of this mass and velocity, such a correction demands a precisely timed application of force rather than passive response. 3 Atlas did not drift into a new path but transitioned smoothly as though executing a planned maneuver. Astrodynamic reconstructions ruled out gravitational interactions with known bodies because no mass distribution along the path of Atlas could account for the observed change. Likewise, no internal rotational instability could generate directional thrust without ejecting detectable material. Around 3 Atlas sensors detected neither gas release nor particulate dispersion, reinforcing the conclusion that motion occurred without mass loss. This absence of exhaust reframed the phenomenon from propulsion to control. 3 Atlas appeared capable of modulating its momentum without violating conservation laws, implying an interaction with space-time fields rather than reactive force. The anomaly associated with Atlas deepened as further data revealed that the trajectory adjustment followed a mathematically smooth curve rather than a stochastic perturbation. Such smoothness suggests continuous feedback, because discrete forces produce discontinuities that were entirely absent from the motion of 3I Atlas. In engineered systems, feedback implies measurement, and measurement implies awareness of state. 3I Atlas therefore behaved not as an inert body responding to external conditions, but as a system maintaining a desired trajectory against them. Emotionally, this realization carried a peculiar calm rather than alarm. There was no evidence of haste or urgency in the maneuvering of Atlas, only patience expressed through precision. 3. Atlas did not correct its course abruptly but gradually, as though optimizing invisibility rather than speed. This behavior aligned with earlier observations of restraint surrounding Atlas, where human technology compensates for uncertainty with excess force. 3 Atlas compensated with exactness. The implication extended beyond propulsion theory into intention, without aggression. 3 Atlas demonstrated the ability to move deliberately through space without announcing itself through energy expenditure. As attention turned towards subsequent anomalies, the trajectory adjustment of Atlas became less an isolated mystery and more a prelude. If 3 Atlas could maneuver without heat, without exhaust, and without error, then motion itself had become a form of communication. The controlled separation event involving 3 Atlas marked a transition from anomalous motion to deliberate deployment. Until that moment, Atlas could still be framed as a singular system exhibiting restraint, but the release of a secondary body altered the interpretive landscape entirely. At a precisely measured point along its trajectory 3, Atlas expelled a smaller structure now designated as 3 Atlas b, and the manner of separation defied every known fragmentation model. Natural breakups occur along stress fractures or rotational limits, yet Atlas b emerged at a clean 90-degree angle relative to the primary path of Atlas without tumbling or loss of coherence. Initial velocity measurements showed that Atlas b matched the momentum vector of 3 Atlas exactly at the moment of release. This synchronization matters because it indicates coordination rather than coincidence, and coordination implies prior calculation within the system of Atlas. Within seconds of separation, Atlas b initiated independent acceleration. The transition from shared motion to autonomous maneuvering occurred without any detectable lag, suggesting that Atlas b was not a passive fragment, but an active component awaiting deployment. Sensors recorded no explosive force, no debris cloud, and no thermal spike at the point of release from 3 Atlas. Instead, the separation resembled an unlocking rather than a rupture, as though Atlas b had always existed as a latent extension of the primary structure. The geometry of the event further reinforced this interpretation. Atlas b did not drift outward along a chaotic vector, but followed a clean orthogonal path that minimized interference with the trajectory of 3I Atlas. Such geometric consideration implies that spatial efficiency was a design constraint rather than an emergent outcome. As Atlas b accelerated, the magnitude of force exceeded tolerances for any known natural material. Sustained acceleration at these levels would pulverize rock, metal, or ice, yet Atlas b maintained structural integrity without deformation or signal noise. The absence of observable propulsion around Atlas b mirrored the earlier restraint displayed by 3 Atlas. There was no exhaust plume, no electromagnetic flare, and no interaction with the surrounding medium that could be classified as thrust. This consistency suggested that Atlas b and 3 Atlas shared a common operational principle. Both entities demonstrated motion governed by control rather than reaction, and separation did not diminish that control but multiplied it. Emotionally, the controlled release shifted interpretation from curiosity to comprehension. 3 Atlas no longer appeared as a lone anomaly passing through the solar system, but as a platform capable of distributing agency. The emergence of Atlas b implied scalability. If one such release was possible, then repetition became a logical extension rather than speculation. In this context, the separation event did not signal escalation through force, but through presence. 3 Atlas demonstrated that it could place autonomous systems into space without altering its own trajectory or revealing excess energy. As Atlas b moved away under its own guidance, the silence surrounding the event became more instructive than any signal. 3 Atlas had not only arrived intact but had begun to act. The acceleration profile of 3 Atlas b introduced constraints that extended beyond propulsion theory and into the fundamental limits of material science. Where earlier anomalies associated with Atlas could be interpreted as control without force, the behavior of Atlas b required force to be acknowledged, even in the absence of conventional mechanisms. Instrumentation tracking. Atlas b recorded sustained acceleration approaching 12 times Earth's gravitational constant. Such acceleration would normally exceed the structural tolerance of known solids, because internal stress scales with mass and velocity rather than with intent. Yet Atlas b exhibited no signs of deformation, fragmentation, or thermal instability as it accelerated away from 3I Atlas. In human engineering, even short bursts of high acceleration require sacrificial design margins because materials fatigue under stress long before catastrophic failure. Atlas b did not display fatigue, and Atlas b did not modulate acceleration to preserve integrity. Instead, Atlas b maintained consistent thrust, as though internal structure and applied force were perfectly matched. Comparative analysis underscored the disparity. The Parker Solar Probe, one of humanity's most resilient spacecraft experiences, accelerations orders of magnitude lower, and even those conditions demand exotic shielding and constant monitoring. Atlas B exceeded those limits by factors so large that extrapolation ceased to be meaningful. The absence of observable reaction mass further complicated interpretation. Acceleration without exhaust implies interaction with spacetime itself rather than expulsion of matter, a capability that remains theoretical within human physics. Atlas B therefore appeared to operate in a regime where inertia could be shaped rather than resisted. This behavior reframed the concept of material entirely. Rather than being a passive substrate subjected to force, the structure of Atlas B appeared integrated with the mechanism generating acceleration. In this configuration, stress was not imposed upon material, but distributed through it as a controlled state. Emotionally, the response among observers shifted from fascination to quiet recalibration. The acceleration of Atlas B did not suggest recklessness or urgency, but confidence rooted in understanding. 3 Atlas had already demonstrated restraint, and Atlas B extended that restraint into motion that ignored thresholds humans consider absolute. The implications reached beyond engineering into epistemology. If material limits could be bypassed through coordination at deeper physical layers, then many assumptions about technological ceilings required revision. Atlas B did not break physics, but suggested that physics had been entered at a level humanity had not yet accessed. As acceleration continued without decay, the distinction between vehicle and environment began to blur. Atlas B did not push against space but appeared to negotiate with it. This negotiation implied symmetry between structure and field rather than opposition. The sustained nature of the acceleration removed the possibility of anomaly through chance. 3 Atlas and Atlas B demonstrated repeatable behavior consistent with design principles, rather than opportunistic exploitation of rare conditions. In this context, acceleration ceased to represent speed alone. For Atlas B, acceleration became evidence of mastery over constraints that humanity still treats as immutable. As tracking data extended forward in time, the question was no longer whether Atlas B could endure such forces. The question became what purpose required such endurance, and why 3 Atlas had chosen to reveal it so deliberately. Trajectory projections associated with 3 Atlas B introduced a final variable that could not be absorbed into abstraction. When extrapolated forward using conservative assumptions, the path of Atlas B did not intersect with the Sun, nor with any major planetary body, nor with regions of gravitational interest. Instead, the projected coordinates converged on a single moving target because Earth itself was the reference frame. Calculations showed that Atlas B was not aiming at where Earth had been, but at where Earth would be. This distinction mattered because it implied predictive modelling rather than reactive navigation. The convergence window resolved into a duration of approximately 41 days from the moment of separation. This interval was not arbitrary because shorter windows would require extreme urgency, while longer ones would suggest passive observation. Atlas appeared to select a timescale consistent with deliberate approach rather than sudden encounter. Astrodynamic models confirmed that no known perturbation could redirect Atlas B toward Earth unintentionally. The margin of error allowed by gravitational noise was orders of magnitude smaller than the observed alignment. 3 Atlas therefore transitioned from being an observer to being a participant in Earth's immediate spatial context. The 41-day interval carried an emotional weight that was difficult to quantify. Atlas did not impose immediacy, but it did not allow distance to remain abstract. Time became a boundary rather than a buffer. Within this countdown, Atlas B maintained consistent acceleration without course correction. Such consistency indicated that the destination had been fixed prior to deployment. 3 Atlas did not adjust plans in response to observation, but appeared to execute a sequence already defined. Importantly, the projected approach did not terminate in collision. Atlas B was calculated to enter stable orbital regimes consistent with observation and monitoring rather than impact. This detail reframed the meaning of arrival from threat to presence. Emotionally, the implication was unsettling precisely because it lacked drama. 3 Atlas did not rush, did not signal alarm, and did not demand response. Atlas simply closed distance at a pace that removed ambiguity while preserving calm. The 41-day marker functioned as a threshold rather than a deadline. It suggested a transition from distant evaluation to proximal relevance. Atlas appeared to acknowledge Earth not as a hazard or a prize, but as a system entering visibility. This interpretation aligned with earlier elements associated with 3 Atlas. geometry established boundary mathematics, established communication dynamics, established control and trajectory, established relation. Each layer reduced uncertainty without escalating force. As the projected date approached, attention shifted away from speculation about intent and toward recognition of circumstance. 3 at last had positioned Earth within a defined frame of reference. Whether this frame represented observation integration or containment remained unresolved. What could no longer be denied was proximity. 3 at last had chosen not to remain distant, and in choosing approach without urgency at last transformed time itself into the final signal. As tracking systems continued to monitor the space surrounding Earth, the behavior of 3 at last revealed a pattern that could no longer be interpreted as isolated motion. Additional entities associated with at last began to appear, each emerging along vectors that were mathematically related rather than randomly distributed. Over time, these trajectories resolved into a 3-dimensional geometry because the objects linked to at last positioned themselves at varying inclinations and distances. When mapped together, the paths of these at last entities formed a near-perfect sphere with Earth at its centre. This configuration carried immediate analytical weight because spherical distribution maximizes coverage while minimizing redundancy. In surveillance theory, such arrangements are not exploratory but observational, and at last appeared to apply this logic with extraordinary precision. Each object associated with at last occupied a position that maintained line of sight to Earth while preserving spacing from other units. The spacing was not static but dynamically adjusted, suggesting continuous coordination across the entire formation. Atlas therefore did not deploy independent probes, but a coherent system behaving as a unified structure. Importantly, the Atlas perimeter did not intrude into Earth's atmosphere or interfere with orbital traffic. Satellites continued to function, and gravitational measurements showed no destabilizing influence. This restraint suggested that the spherical arrangement surrounding at last was designed for observation rather than domination. The geometry of the formation also excluded randomness. A sphere does not emerge naturally from uncoordinated trajectories, particularly when those trajectories originate from a common source like at last. The probability of such alignment occurring by chance was effectively zero. Emotionally, the recognition of a spherical perimeter produced a subtle but persistent unease. Atlas did not surround Earth abruptly, and Atlas did not announce enclosure. Instead, Atlas allowed the realization to emerge gradually, as data accumulated into pattern. In ecological systems, encirclement often precedes classification rather than attack. Predators rush, but observers wait, and Atlas demonstrated patience rather than urgency. The spherical formation also reframed Earth's position. Rather than being one object among many, Earth became the reference point around which at last organized space. This inversion of perspective altered assumptions about significance without invoking threat. From a systems viewpoint, the Atlas perimeter functioned as a boundary condition. Inside the sphere, processes continued normally, while outside the sphere, monitoring persisted without intervention. Such boundaries do not constrain movement, but they redefine context. As awareness of the formation spread, interpretation shifted from curiosity to comprehension. 3 at last was no longer passing through the solar system. 3 at last had established a spatial relationship that placed Earth within a defined observational field. The spherical arrangement established by 3 at last reframed a question that has lingered unresolved for decades because the apparent silence of the universe could no longer be interpreted as absence. Rather than asking why humanity had not encountered other civilizations, the configuration surrounding at last suggested that encounter itself may be conditional. The traditional formulation of the Fermi paradox assumes that advanced civilizations would inevitably expand, broadcast, or leave detectable traces. 3 at last challenged that assumption by demonstrating that capability does not require visibility, and that restraint can be a strategic choice rather than a limitation. If civilizations mature beyond the impulse to announce themselves, then silence becomes a feature of governance rather than a symptom of emptiness. In this framework, Atlas did not represent an exception to the paradox, but an illustration of its solution. The presence of Atlas implied that advanced intelligences may operate under protocols that regulate contact based on developmental thresholds. Rather than expanding indiscriminately, such civilizations could limit interaction until emerging species exhibit stability, comprehension, and restraint. 3. Atlas therefore suggested a universe that is structured but selectively opaque. Civilizations may coexist across the galaxy, while remaining effectively invisible to one another until specific criteria are met. This interpretation resolves the paradox without invoking rarity or self-destruction. Intelligence may be common longevity achievable, and expansion restrained by design rather than failure. The spherical observation field associated with ATLAS reinforced this idea, because surveillance without interference allows assessment without contamination. 3 ATLAS appeared to embody a principle of non-disruptive observation, where awareness precedes engagement. In such a system, humanity's long-standing searches would fail, not because no one was listening, but because humanity was not yet addressable. Signals broadcast into space may have been received catalogued and contextualized without response. Emotionally, this solution carried a quiet inversion of expectation. Instead of being ignored, humanity may have been intentionally unacknowledged. 3 ATLAS reframed cosmic loneliness as developmental privacy. Just as ecosystems mature unseen beneath the surface, before emerging into visibility, civilizations may remain uncontacted until interaction becomes meaningful rather than destabilizing. The paradox dissolves under this perspective because silence no longer signals emptiness. Silence becomes evidence of order operating beyond human perception. On December 29th, scientists began reporting a series of anomalous features associated with 3 ATLAS, including an extremely high rate of mass loss that appeared concentrated in specific regions, the object's ability to maintain a coherent monolithic structure rather than fragmenting like a typical comet indications of a metal-rich core, and jets with unusually stable orientations that evoke the idea of guidance or propulsion mechanisms. These observations were accompanied by structured electromagnetic pulses synchronized with changes in rotational behavior, as well as optical and thermal variations that are difficult to explain using conventional models. However, shortly after detailed measurement reports were received, the international scientific community was said to have entered a highly questionable protocol of silence, as many experts abruptly shifted from an open and enthusiastic stance to downplaying or denying the very anomalies they had previously acknowledged. What then caused the strange features of ATLAS to be obscured, and what truly lies behind this sudden change in narrative? We will explore these questions next. As 3 ATLAS approached Earth in December, astronomers calculated its path with increasing precision. The flyby of 3 ATLAS reached its closest point on December 19th, at a distance of roughly 269 million kilometers. At that range, 3 ATLAS was never a spectacle for the naked eye, and yet its presence quietly mobilized an extraordinary network of instruments across the planet and in space. Telescopes on mountaintops, radio arrays spread across continents, and spacecraft such as the JUICE mission were all redirected to follow 3 ATLAS. Every observation of 3 ATLAS was remote, patient, and indirect, relying on photons and subtle variations in motion rather than dramatic visual display. This distance is important because it defines the limits of certainty that surround 3 ATLAS from the very start. In official summaries, 3 ATLAS was introduced to the public as a rare but natural event. 3 ATLAS was described as an interstellar comet passing through the solar system once and never to return. Within this framing, 3 ATLAS appeared to be an object already understood, requiring no new categories or unsettling revisions. Yet beneath these calm descriptions, the raw observational timeline of 3 ATLAS tells a more complex story. The approach to the brief flyby and the rapid departure of 3 ATLAS unfolded over days, not years, compressing analysis into an unusually narrow window. This compression created a sense of urgency around 3 ATLAS, even as the language used to describe it remained deliberately restrained. As 3 ATLAS moved away from Earth after the flyby, its physical presence diminished, but its analytical weight increased. The departure of 3 ATLAS marked the end of direct proximity, but it marked the beginning of deeper questions. In this quiet gap between observation and interpretation, 3 ATLAS began to feel less like a passing object, and more like a problem left unresolved. As 3 ATLAS moved through the inner solar system, measurements of mass loss began to draw focused attention. 3 ATLAS was shedding material at a rate estimated near 1.8 million kilograms per second during the peak of the Earth flyby. For an object of the inferred size of 3 ATLAS, this number immediately stood out as extreme. In conventional comet science, mass loss is driven by solar heating. As sunlight warms the surface of a comet ice's sublimate, dragging dust outward in a diffuse and largely chaotic flow. Under this model, 3 Atlas should have displayed a broad irregular coma gradually thickening as heating increased. What observers found instead forced a pause. The mass loss of 3 Atlas was intense, yet it did not appear evenly distributed. Data streams associated with 3 Atlas suggested concentrated regions of activity, rather than a uniform release across the surface. This distinction matters. If 3 Atlas were behaving like a typical dirty snowball, the sheer violence of losing millions of kilograms per second would normally destabilize the body. Rapid mass loss in ordinary comets often leads to fragmentation, spin chaos, or complete structural failure. 3 Atlas did not immediately follow that script. Despite the magnitude of the material being expelled, the overall form of 3 Atlas remained coherent during the observation window. The expected cascade toward disintegration did not fully arrive when models predicted it should. This discrepancy introduces the first quiet anomaly. 3 Atlas appeared to tolerate an enormous energetic burden without collapsing into randomness. The material leaving 3 Atlas behaved less like debris from a failing structure and more like output from defined regions. Such behavior does not automatically imply intent or design. Nature is capable of producing edge cases, especially in environments formed around other stars. Still, the pattern of mass loss observed in 3 Atlas does not rest comfortably within familiar cometry statistics. At this stage, the safest conclusion remains narrow. 3 Atlas is losing mass at an exceptional rate, and that loss is not obviously chaotic. Whether this reflects an unusual composition, a rare structural arrangement, or something not yet categorized remains unresolved. As 3 Atlas continued outward, the mass loss rate gradually declined, yet the memory of that peak value lingered in the data resistant to easy dismissal. In the slow review of these measurements, 3 Atlas quietly challenged assumptions without ever announcing why. The unusual pattern of mass loss invites a careful hypothesis rather than a conclusion. One possible framework proposed by some analysts is that 3 Atlas was not simply eroding, but shedding material in layers. This idea is sometimes described as a deployment or shedding layers hypothesis, and it attempts to remain grounded in physics while acknowledging the anomaly. In this view, the surface of 3 Atlas may consist of multiple strata, formed in an environment very different from the solar system. As 3 Atlas encountered increasing solar radiation, these outer layers could have detached in a controlled sequence, rather than dissolving all at once. Such a process would still be driven by energy input from the Sun, yet the response of 3I Atlas would appear structured instead of chaotic. Data supporting this hypothesis comes from the uneven distribution of activity. Regions of 3I Atlas appeared to activate while other areas remained comparatively quiet, for 3I Atlas. This selective behavior suggests differences in composition or binding strength across its surface. Under ordinary comet models, layered shedding is not common, but it is not forbidden. Certain comet nuclei show patchy activity when volatile pockets are unevenly distributed. However, 3 Atlas pushes this idea to an extreme scale, both in rate and apparent order. Another element of the shedding layers hypothesis involves rotational stability. As mass leaves a rotating body, angular momentum usually changes in unpredictable ways. In the case of 3 Atlas, the loss of material did not immediately lead to rotational chaos. Instead, observations hinted that 3 Atlas adjusted without catastrophic spin disruption. This suggests that material may have been lost in a way that reduced stress rather than amplified it. For 3 Atlas, shedding mass could have acted as a stabilizing process instead of a destructive one. It is important to emphasize restraint here. The shedding layers hypothesis does not require intention awareness or technology. It simply proposes that 3 Atlas possesses an internal structure capable of responding coherently to external heating. If this hypothesis is correct, 3 Atlas would represent a rare outcome of planetary formation around another star. The object could be a relic with a hardened core and sacrificial outer shells, shaped by conditions we have not yet sampled directly. In that sense, 3 Atlas would expand the known diversity of natural bodies rather than overturn it. Yet the hypothesis remains provisional. No direct imaging of internal layers exists, and remote sensing offers only indirect clues. For 3 Atlas, the shedding layers idea functions as a bridge between familiar physics and unfamiliar behavior. As 3 Atlas continued its outward journey, the question remained open. Was this shedding merely an exotic natural response or the surface expression of something deeper? At this point in the narrative, 3 Atlas does not answer. It only invites the next question. Spectral analysis added another layer of complexity to the portrait of 3 at last. As light reflected from 3 at last was separated into its component wavelengths, unexpected signatures began to appear. Among the familiar markers of volatile ices, astronomers detected unusually high concentrations of heavy metals. Nickel and iron stood out most clearly in the data from 3I Atlas. These elements are not entirely absent from comets, but they are typically present only in trace amounts. In the case of 3I Atlas, the inferred abundance of nickel and iron suggested something far more substantial than surface contamination. Heavy metals imply density. For 3I Atlas, density raises immediate questions about internal structure and mechanical strength. A body rich in metallic material would behave very differently from the porous, fragile aggregates that define most known comet nuclei. This observation naturally leads to the idea of a monolithic core. If 3 at last contains a dense central mass, that core could explain the object's ability to survive intense mass loss without immediate collapse. A solid or semi-solid interior would distribute stresses more evenly as material leaves the surface of 3I Atlas. Such a core does not require an artificial explanation. Planetary formation models allow for metal-rich bodies to emerge, especially in systems with different chemical histories. 3I at last may have formed near a metal-rich star or within a protoplanetary disk unlike our own. Still, the implications are significant. A monolithic core would place 3I at last at the far edge of known cometary behavior. Most comets fragment easily because their internal cohesion is weak, held together by gravity and ice rather than strength. 3I Atlas appeared to resist that fate, at least during the observed interval. The presence of heavy metals offers one possible reason for that resistance. It suggests that 3I Atlas may be less of a loose pile and more of a structured object. This idea connects back to the earlier patterns of mass loss. If 3I Atlas is built around a strong core, shedding outer material could occur without threatening the integrity of the whole. In this scenario, the core of 3I Atlas remains largely unaffected while the surface adapts to environmental stress. There is also a temporal aspect to consider. Metals exposed on the surface of 3I Atlas would normally oxidize or erode over long timescales. The fact that these signatures remain detectable implies either recent exposure or persistent replenishment. Neither option is trivial. Recent exposure aligns with the shedding layers hypothesis, where deeper material becomes visible as outer shells are lost. Persistent replenishment would require ongoing processes within 3 Atlas that are not yet well understood. At this stage, caution remains essential. Spectral data carries uncertainties and interpretations depend on models with inherent assumptions. Yet the heavy metal signals associated with 3 Atlas cannot be dismissed as noise. They reinforce a growing impression. 3 Atlas is not merely unusual in motion, but unusual in substance. As the narrative moves forward, the dense heart of 3 Atlas becomes a quiet anchor for questions that have only begun to surface. Before December 25th, the scientific conversation surrounding 3 Atlas unfolded in an unusually open and exploratory manner, shaped by the recognition that this was only the third confirmed interstellar object ever observed passing through the solar system. Because 3 Atlas arrived without precedent that could fully constrain expectations, researchers allowed a wide spectrum of interpretations to coexist, and this provisional openness created a rare moment where uncertainty was acknowledged rather than suppressed. In the days leading up to the Earth, flyby preliminary data sets from ground-based observatories and early spacecraft telemetry were shared rapidly, often accompanied by tentative commentary that emphasized how incomplete the picture of 3I Atlas still was. Within this atmosphere, 3I Atlas became a focal point for hypothesis-driven discussion, where unusual acceleration, structural resilience, and early spectral hints were framed as questions rather than conclusions. Public-facing scientists and institutional projects reflected this tone by openly stating that 3 Atlas did not yet fit neatly into established cometary categories, while also stressing that nature frequently surprises observers when samples are drawn from unfamiliar stellar environments. At this stage, references to exotic possibilities surrounding 3 Atlas were presented as intellectual exercises rather than claims, and they were explicitly balanced with reminders about statistical rarity and observational bias. The presence of high-profile voices contributed to the visibility of this speculative phase, as interviews, preprints, and conference remarks treated 3 Atlas as an opportunity to test the flexibility of existing models without immediately enforcing interpretive boundaries. Importantly, this period was not characterized by sensationalism alone because 3 Atlas was repeatedly described as a puzzle. whose solution would depend on additional data rather than rhetorical confidence. As more instruments were retasked to observe, the flyby coordination among observatories increased, and the expectation emerged that the closest approach of 3I at last would clarify which hypotheses deserved further attention. The prevailing assumption was that greater resolution would either reinforce conventional explanations or gradually narrow the space for alternatives, and this assumption shaped how early speculation around 3 Atlas was tolerated. During this window, uncertainty was treated as a temporary condition rather than a threat, and the scientific culture surrounding 3 Atlas appeared willing to accept ambiguity as a natural stage in the process of understanding. This openness was sustained precisely because the most sensitive datasets had not yet been fully integrated, allowing 3 Atlas to remain an unresolved subject rather than a closed case. In retrospect, the period before December 25th now appears less like a chaotic outburst of conjecture and more like a brief equilibrium where curiosity and restraint existed side by side around 3 Atlas. It was an interval defined by the belief that forthcoming data would guide interpretation organically, and it is this expectation rather than any single hypothesis that would soon be disrupted. After the high-resolution telemetry from the JUICE mission was downloaded and internally reviewed, the tone surrounding 3 Atlas shifted with a speed that surprised even seasoned observers. What had previously been framed as an open scientific puzzle suddenly began to resolve into a single narrow interpretation, and the range of publicly discussed possibilities around 3 Atlas contracted almost overnight. In official briefings released after the JUICE data integration, 3 Atlas was described with renewed confidence as a natural object undergoing ordinary if energetic cometry processes. Language that once emphasized uncertainty was replaced by phrasing that implied closure, and references to unresolved anomalies associated with 3 Atlas became noticeably rarer. This reversal did not occur gradually as competing analyses converged. Instead, the narrative surrounding 3 Atlas appeared to flip discreetly, as if a threshold had been crossed behind the scenes and a decision about interpretation had already been made. Prior to the JUICE download, researchers openly acknowledged that available models struggled to account for the combined behavior of 3 Atlas. After the JUICE data entered circulation, statements increasingly emphasized that all observed features of 3 Atlas could be explained within existing physical frameworks, even when those explanations required unusual parameter choices. The shift was particularly evident in how speculative language was handled. Where earlier discussions allowed that 3 Atlas might challenge standard assumptions, later communications reframed those same challenges as misunderstandings or artifacts of limited perspective. 3 Atlas was no longer positioned as an outlier demanding careful expansion of theory, but as an object whose oddities were already understood in principle. This change created an asymmetry between data availability and interpretive certainty. While conclusions about 3 Atlas grew more definitive, the underlying data sets that justified those conclusions were not released in parallel. In place of raw measurements, summaries and interpretations were offered, asking the broader community to accept results without direct access to their foundations. The coordination of this narrative adjustment was subtle but consistent. Across multiple institutions, descriptions of 3 Atlas converged toward the same explanatory language, and alternative framings quietly disappeared from official channels. No explicit prohibition was announced, yet the boundaries of acceptable interpretation around 3 Atlas became increasingly clear. From the outside, this transformation resembled a stabilization process rather than a debate. The scientific system appeared to be dampening oscillation, reducing interpretive noise, and guiding attention back toward familiar ground. In this process, 3 Atlas shifted from being an object that invited open-ended inquiry to one that exemplified the resilience of existing models. Whether this convergence reflected genuine resolution or institutional caution remains difficult to determine. What is clear is that the arrival of JUICE data marked a dividing line in how 3 Atlas was discussed. Before the download, uncertainty was visible and tolerated, but after it, uncertainty receded from public view, leaving behind a narrative that felt settled long before its supporting evidence was fully seen. As attention turned toward the supporting evidence behind the revised explanations, observers began to notice that the public record surrounding 3 Atlas was incomplete. While summaries and interpretive statements multiplied, direct access to raw datasets became increasingly limited, creating an unusual imbalance between confidence and transparency. For an event involving an object as rare as 3 Atlas, this absence stood out sharply. High-interest astronomical events typically generate rapid-release archives, where preliminary data are made available for independent verification. In the case of 3I Atlas, several expected data products were delayed, redacted, or omitted entirely without detailed explanation. The most visible gaps appeared as temporal discontinuities. Observation logs associated with 3I Atlas showed periods of hours where no publicly accessible measurements were listed despite instruments being scheduled and operational. These gaps were not framed as anomalies, but were simply left unaddressed in official releases. Raw telemetry is the backbone of scientific accountability. Without it, interpretations of 3 Atlas cannot be independently tested, reproduced, or meaningfully challenged. Instead, the community was asked to rely on processed conclusions separated from the underlying signals by layers of institutional filtering. This pattern raises questions that extend beyond any single data set. 3 Atlas was observed by multiple platforms across different wavelengths, yet the completeness of those records varied unevenly. Some instruments released detailed outputs, while others referenced results without providing the associated raw material. In ordinary circumstances, such delays might be attributed to calibration pipelines or quality control. However, the timing of these absences coincided closely with the narrative shift around 3I Atlas. What had been an open flow of provisional data before the JUICE integration became a controlled stream of finalized statements afterward. The issue is not that missing data proves concealment. Science often operates with imperfect archives and logistical constraints are real. The concern arises because the gaps surrounding 3 Atlas appear selectively aligned with the most anomalous measurements. When raw data is missing, anomalies cannot be resolved, only reinterpreted. This dynamic effectively freezes 3 Atlas in a state where uncertainty is present but inaccessible. The object remains unusual, yet the tools required to explore that unusualness are out of reach. For independent analysts, this creates a structural asymmetry. They are expected to evaluate claims about 3I Atlas without access to the evidence that produced those claims. Such a condition weakens the self-correcting mechanisms that science relies upon. At this stage, the absence itself becomes part of the phenomenon. The missing data associated with 3 Atlas does not speak, yet it shapes interpretation by limiting what can be questioned. In this silence, 3 Atlas continues its departure, leaving behind not only unanswered questions, but also the outline of information that was never fully shared. As discussion moved from observation to governance, the question of institutional pressure began to surface around 3I Atlas. When scientific narratives shift rapidly and data access narrows, it becomes reasonable to examine whether forces beyond pure analysis are influencing interpretation. Large observational campaigns involving rare interstellar objects intersect with more than academic curiosity. 3I Atlas was tracked by assets that also serve strategic and security-related functions, including space-based sensors and deep space communication networks. In such context, the boundary between open science and classified capability is not always clean. From an institutional perspective, uncertainty carries risk. If 3 Atlas were framed as fundamentally unexplained, it could invite public speculation that extends beyond scientific domains into political or security discourse. Managing that risk often incentivizes conservative explanations that minimize disruption. This dynamic does not require an explicit act of censorship. Pressure can manifest indirectly through funding priorities, review processes, and the informal norms that shape what is considered responsible communication. Researchers working on 3 Atlas operate within systems that reward stability and penalize controversy, especially when claims intersect with national infrastructure. Security considerations further complicate transparency. If any signal or behavior associated with 3 Atlas overlapped with frequencies detection methods or analytical tools used in defense contexts, classification could be triggered automatically. In such cases, scientists may be restricted from discussing details not because of intent to mislead, but because of legal obligation. This creates a subtle form of narrative compression. Public explanations of 3 Atlas gravitate toward interpretations that can be safely discussed without revealing sensitive capabilities. Alternative framings, even if scientifically plausible, may be sidelined simply because they touch restricted domains. The result is a version of consensus that emerges from constraint rather than convergence. 3. Atlas appears increasingly settled in official discourse, not necessarily because anomalies have been resolved, but because unresolved elements cannot be openly addressed. For observers outside institutional boundaries, this pattern is difficult to evaluate. The absence of visible debate around 3E Atlas can be mistaken for certainty when it may instead reflect caution. This ambiguity blurs the line between scientific judgment and procedural necessity. In this environment, 3E Atlas becomes more than a physical object. 3E Atlas becomes a test case for how modern science operates under layered pressures of security funding and public expectation. Whether these pressures protected clarity or constrained it remains unresolved, but their influence on the narrative surrounding 3E Atlas is difficult to ignore. As analysis shifted toward the geometry of the jets, 3E Atlas began to challenge one of the most stable assumptions in comet physics. Jets are expected to emerge from fixed surface regions and to rotate passively with the body as it tumbles through space. In the case of 3E Atlas, the observed jets did not fully conform to that expectation, and this deviation became increasingly difficult to ignore. High-resolution imaging suggested that several jets associated with 3E Atlas maintained preferred directions for extended periods. Even as the nucleus of 3E Atlas exhibited changes in rotation, the orientation of these jets appeared less tightly coupled to surface rotation than models predicted. This observation formed the basis for what is now described as the vectoring jets question. In spacecraft engineering, thrust vectoring refers to the ability to control the direction of exhaust independently of the vehicle's orientation. For 3E Atlas, no control surfaces or mechanical structures were observed, and no claim of propulsion is required to recognize the similarity in behavior. The point of comparison lies not in intent but in outcome. If a natural jet is fixed to a rotating surface, its direction in space should sweep predictably. Data associated with 3E Atlas suggested a different pattern, where jet orientation drifted more slowly or corrected itself relative to the overall spin. This discrepancy is subtle, but its persistence across multiple observations gives it weight. Several natural explanations have been proposed. One possibility is that internal channels within 3E Atlas redirect material flow, allowing exhaust to emerge at angles not directly tied to surface rotation. Another is that uneven mass loss alters the moment of inertia of 3I Atlas, producing transient stability that mimics control. Each explanation stretches known physics without breaking it. However, when combined with the intensity of the mass loss, these explanations begin to strain. For 3 Atlas, maintaining directional coherence under such energetic conditions requires either exceptional internal structure or coincidental timing. The data does not prove active guidance. It does, however, indicate that the jets of 3I Atlas behave differently from the statistical norm established by solar system comets. This distinction is important because it defines the boundary between anomaly and explanation. As analysts examined frame sequences more closely, oscillations in jet brightness and orientation were noted. These oscillations appeared synchronized with changes in the rotational behavior of 3 Atlas, suggesting a coupling between mass ejection and angular adjustment. In ordinary cometary activity, such coupling is weak and poorly organized. For 3I Atlas, the apparent feedback between rotation and jet behavior hints at an internal system responding dynamically to stress. Whether that system is geological, structural, or something not yet categorized remains open. The key point is that on December 28th, a scientific speculation emerged suggesting that the James Webb Space Telescope had detected